Hi, this is Robert Greer for SE456 Milestone 1. I'll start by showing each of the design patterns. For singleton, I have the sprite box manager. It's a singleton with a public static create and destroy. Create initializes the static instance. And then I have a public static interface that I'll each call the getInstance method and then call a private implementation method. Next is factory. Here's the alien factory. It has a create method that takes an enum. It does a switch statement on the enum and initializes the underlying type that I want, and then does some setup on that object and returns it. Next is object pools. Here's my manager base. It has an active list and a reserve list. The diagram looks like this. And whenever I create a new active node, I always pop from the reserve and then add it to the active to recycle those nodes. Next, we'll do priority queue. Here's the timer event manager. When I insert a new timer event, I calculate the trigger time and then I insert it in order based on that trigger time with this comparison function. And then when I want to call the timers, I iterate over my timer list, which I know are in order. And if the time is passed, I process. Otherwise, I early out. Next, for proxy, here's my proxy diagram. I have under sprite base, there's proxies and then real sprite games. So proxy has a pointer to the sprite as well as its own XY value. This allows me to render the same sprite at different locations, and I just pass on all of the functionality from the proxy to the real sprite here. Next, for command. So I'll show my alien movement command. The command base class just has an abstract execute. In the execute here, I grab my grid, I iterate over all the objects in the grid, and I adjust their location. And then I add it back as a repeat command to get that functionality. Okay, next for iterator, I'll use sprite batch manager to show that in draw. We iterate over, we grab the iterator from the base class, and then we do the standard for loop, and we just call draw on each of the elements. Next for template, so in manager base, when I need to create a new node, I pop it from the reserve. When I need to grow the reserve pool, I then need to initialize a new object. So I call derived create node. This is because the manager base doesn't know the type of thing it's trying to create, so it calls the derived. So an example of that is here in derived create node. In this case, I initialize a new sprite batch and return that to the base class to use. So it can initialize the type without knowing what it is. Next, we'll do composite. So here's the diagram of composites. Game objects are all components, and then you can have either a composite or a leaf game object. The composites have a D-Link manager, which contains other components. And the key functionality that I'm doing here is this update of the composites where they calculate their collision object dimensions based on the union of subobjects, which we'll go into later. But that's the key thing with the composites. So if we look at the assembly here, I initialize a grid of aliens, and then in my for loop, I initialize a column, and then I add all the aliens in that column to the column composite, and then I add the composite column to the composite grid, and that gives me my hierarchical structure. Next, I'll do null object. So here I have sprite null and sprite proxy null, and these are just versions of the sprite that do nothing. I use this in the composite. For example, I always request a sprite null as my sprite. And the way this works is that in my sprite managers for both proxy and real sprites, I initialize a null object so that that always exists and I can always use it. And then in the batch manager, when I draw, I don't have to check for the sprite if it's null or not. I always just call draw. And if it's the null object, it'll do nothing. Okay, next for the adapter, we'll do texture. So here's texture. It has a pointer to the underlying Azul texture, and then it provides all the functions you need to interact with that texture. So it's just adapting that underlying texture type. Okay, and then for labeling all news, I can go through a few examples of that. So for example, here I have some long-term news. Most of them are initializing member variables and things like that. The only short-term new I found was my factory here, which I'm only using once to set up the aliens. Everything else is just being passed in to be owned by something else or initializing a member object. Okay, and last for the object pooling in real time. So I added some print statements for my batch manager. So I'll use the demo to show this. So you can see when I start running the demo, I have 2 batches on my list, aliens and boxes. And when I toggle the boxes, it adds my boxes to the reserve list. So now I only have aliens on the active. And then when I want to add the boxes back, it's going to take that off the reserve list and put it back onto the active. So that is how the object pooling is working. Okay, so that's all the things on the checklist there. Now I'm going to go through the new features that make the demo work. As I already showed, we have the composites, and we have these collision boxes that are being drawn. So the collision object is here. It just has a rectangle that gets drawn, and it looks like this. It has the rectangle and the sprite, and then the composites and the leaves own the collision objects, but they render them in a little bit different ways. So the composite is where that gets interesting because it has a list of other game objects. And so when I update it, I loop over all those game objects, or rather I iterate through them with my complicated composite iterator. And I calculate the union of all of those. And that gives me this union shape that I draw with that collision object. So let's look at that here. So you can see the aliens have the yellow boxes around them. That's just their own collision box. And then the column that they've been added to is the union of all of those alien boxes. That's in red. And then the grid is the union of all of its elements, which is each of the columns. So that's cool. It's kind of a derived calculation of those shapes, which works well. So yeah, that's the composite and the collision boxes. Now for the actual functionality of the demo, as you can see here, it mimics what it's supposed to look like. The animations and the movement are both on 0.5 second timers. I can press the 1 key to disable the boxes and then add them back. So there's that. And then, yeah, so I can show where some of the values are set up just to verify that those are correct. A lot of the values in setup aliens are here based on the specification. And then also in the movement command, I have a lot of the values set up there to be correct. So yeah, that's my demo. It's all working properly. And that is Milestone 1. Thank you.